What is up guys, I'm Shivam Pandey and you are watching The Techpreneurs. So today we'll learn the basics of networking and multiplayer in Unity using UNET by creating a very basic multiplayer game coming up.
Before starting, please subscribe to The Techpreneurs and press the bell icon for more game dev related content like this. So we'll start by creating a new project in Unity, and I have created a new one and set the template to 2D. Now in most of the games you must have seen some kind of manager script like a player manager script, game manager script, a sound manager script, a script manager script, and something like that. So in multiplayer games you have to create a network manager script to control all your networking stuff. But at this point it might seem very overwhelming to create a network manager script, but you do not need to worry because Unity has a bunch of networking scripts for us that we can use in our game, and it will make a process a bit faster. So we'll start by creating an empty game object and naming it as network manager. Okay, now when we go to add components, there is a section named network, and this section contains all the pre-made scripts made by Unity that we can use in our networking process. Now at this time we need the network manager component. Now our network manager script is almost set up. Now we need some way to interact with this script. For that we'll go to add components, network, and click the network manager HUD component or script. This script is responsible to give us the UIs to interact with the network manager. Now if I hit play, you can see that some UIs arrived on the screen, and this is because of the network manager HUD component. And you can now interact with the network server, like you can start the server as a LAN host, you can enter another server as a LAN client, and something like that. So the basic functionality of networking has been enabled in your game. Now if you see the console window, you can see that there is an error here, and it says that the player prefab is empty on network manager script. So what this error is that whenever a user is connected to a network, either as a server or host or a client, then a particular game object must be spawned corresponding to that player, and that game object is responsible for all the connections made in the server with other clients and with the network manager. So let's create our player prefab now. For that I'll right click here and create an empty game object and rename it as player. And all the game objects that are spawned inside the server should have their own particular network identity. For that I'll go to add components and network and assign it a network identity. Now this class has two different checkbox. The first one is the server only, and the second is the local player authority checkbox. Server only game objects are those game objects that are spawned in the server and the server has control over them, and the local player authority game objects are those game objects which are controlled by their corresponding users only, and rest other users can't control it. So we want this, so I am checking the local player authority checkbox now. Now let's create the body of our player. For that I'll create a new sprite, a square sprite. Okay, and here I'll create a new empty game object. I'll rename it as body. Now we need a sprite renderer for it. I'll write sprite renderer, and in this I am going to specify this square sprite and set the color to black. So this would be the body of our player prefab. Also I am setting the background color of the main camera to white for now. Now if I hit play and start the server as a LAN host, you can see that our player prefab, which we have configured in the network manager, is now available here, and in the console you can see that there is no error messages now. And now if I go to the files and build setting and build and run this project into a new window, now I have two game windows open, one in the editor and one in the build we have done right now, and these two can act as two different players in one server. I'll start this server by creating a LAN host in my editor and LAN client in my this. Now you can see that two different player prefabs are created here. One is in the authority of the editor user and one is in the authority of the build user. And now you can see that both of the player looks exactly similar, and you have no way to distinguish which is your player and which is the other player. So we need to create some script to enable this functionality. So let's create a player script now. I'll right click and create a new C# script and name it as player src and open it upon Visual Studio. So this is the player script we have created, and what I want from this script is that since all the devices connected to the server are having the same player prefab, so to distinguish them, what I want is the local player of each device should be of blue color and rest of the players should be of red color. Let's start by removing these two using tags, and also we need to add another using tag for enabling the network functionality, and it is the Unity engine dot networking using tag. Also we need to derive a class instead of mono behavior to network behavior. By doing this we can get all the functionality of mono behavior as well as the networking functionality. Now suppose there are two devices connected to the server. Each device will have its own player prefab and each player prefab will have its own player script. Now we have to check in each device which player is our local player and which player is the other player. Now you must remember that in the network identity script we have checked the local player authority checkbox. That means that each player prefab spawned in the server will have only one device controlling it, and conversely we can say that each device connected to the server will or can control only one player, and that player prefab is the local player of that device. So we need to check which player is the local player and set the color to blue, and which player is the other player and set the color to red. So to check that functionality we'll use the if statement, and inside the bracket I'll use the is local boolean value that is available in the network behavior class. So for a particular device, is local is true for the local player and other player prefabs will have is local equals to false. So if for a particular device is local is true for a specific player prefab, then we should change the body color of that prefab to blue, else we'll change the body color to red. For that we need firstly the reference of the body, so I'll create a public game object and it should be body. Okay, and here we'll get the reference of the sprite renderer of the body, so we'll go like body dot get component, sprite renderer, yes, and if the player is local then sprite renderer dot color equals blue, and color dot blue, and if the player is not local, that is if it is the other player, then the sprite renderer dot color of the body should be red. Now in the editor, if I select the player prefab, open the prefab, and I'm going to add the player script in this. Yes, and now I'll drag and drop the body in the empty slot, and with the help of Control B I am going to build this project. So now we have two different instances of our game, and these two can be treated as two different devices on the server. The first one is the device 1 and the second one is the device 2. Now in first device, if I start the server as LAN host, you can see that we have a player prefab of blue color, and since it is the local player of this device, so that's why it is of blue color. Now if I join this server with another device as a LAN client, you can see that in both the devices we have a blue and a red colored player, but both of them are in opposite direction in both of these devices. In the first device you can see that this is the local player, that's why it is of blue color, and this is the other player, that's why it is of red color. Now since this is the local player of device 1, so it is the other player of device 2, so it is red in this device, and since it is the red colored player or the other player of device 1, so it is the local player of device 2, that's why it is of blue color in device 2. So by this way, using the is local player boolean value present in the network manager class, you can distinguish between a local player and other players for a particular device. Now after this we need to add two more important things for our multiplayer functionality. So as you have seen that when we started the server either as a LAN host or joined the server as a LAN client, in both the cases our players were spawning at the same place, that is 000 coordinate. So we need to specify a specific spawn point for our players. For that we'll create an empty game object in the scene and name it as spawn points. This would be the parent game object, and inside this I'll create two empty game objects. Yes, and rename it as spawn points. Okay, and I'm going to specify the x coordinate of the first one as -1 and the x coordinate of second one as 1. And to specify them as the starting position of our player prefabs, we have to add another component to them, that is the we'll go to the network section and add the network start position component. So this component will tell Unity that if a player is spawned, then it has to start its position from either of these two spawn points. Now in the network manager, if we go to the spawn info section, then you can see that there is a player spawn method and it has two options, either a random or round robin. So this method is responsible how the player prefabs are spawned inside the scene. If we select the random option, then the players would be randomly spawned in any one of these two spawn points. But if we click the round robin function, so suppose we have 4 players, so the first one will be spawned in the first spawn point, second player would spawn in the second spawn point, and the cycle would go on. The third one will be spawned in the first spawn point, and fourth one will be spawned on the second spawn point. So round robin is a cyclic process, while random, as its name suggests, is a random process. So for our game now, we need our players to be spawned in round robins. Also, the player prefab is a local player authority, so it is only controlled by one device, but its transform should be synced with all the other devices that are connected to the server. So to do that, we will open the player prefab and add another component. We'll go to the network section and add a network transform component. This component will be responsible to sync the transform of our player prefab from one device to all other devices. And you can see there are much of the components here. We'll focus on only 2 of them now. The first one is network send rate. It is the rate by which the transform would be synced, and we'll put this to the highest number, that is 29, and we are going to sync the transform of our player prefab. Also, we need to sync our body of our player here also. So for that, we'll add a component. From the network section, we'll add the network transform child component, and here you can see the target child transform. For that, we'll drag and drop body here. Yes, and we'll also sync the transform to the fullest rate, that is 29. So by these two scripts, we are syncing the transform of our player prefab with its child component body from one device to all the devices. So any change in the transform of the player in one device is visible in all other devices, and there is no such ambiguity between their transform. So let's code some movement of our player. For that, we'll need two public floats, and the first one is move force and the second one is torque. These two are the forces and the torques that are applied on the body game object, and to apply these two, we also need the reference of the rigid body of this body game object. For that, I'll create a rigid body 2D variable, and I'll name it as RB, and in the start method, I'm going to reference this RB equals to body dot get component rigid body 2D. Rigid body 2D, like this. Now this RB will store the rigid body of the body component. Now you can see that I have not put this inside this if condition, because no matter the player is local or other player, we want the rigid body component of its body game object to be referenced in RB. Now let's add some force to the rigid body RB in the update function. For that, we'll go like RB dot add force, and this accepts a vector 3. So for that, we will create a new vector 3 like this, and for the x coordinate of the vector 3, what we want is input dot get axis horizontal Yes. So what this statement will do that this statement is used to identify the direction of the key press. For example, if you press the right arrow key, then it would return a 1 value. If you press the left arrow key, then this statement will return a -1 value. And if you do not press either the right or the left value key, then this statement will return a 0. So now this statement will be used to identify the direction in which we want the force to be applied to the rigid body in x-axis. So now we know the direction, we are going to multiply the direction by the force we want to apply, move force. So for example, our move force is 100 and we press the right arrow key, so this whole statement will be like 1. So the in the x-axis the force applied to RB would be equal to 100, and if we press the left arrow key, then this statement would be equal to -1. So the force applied to the RB would be -100 and it will move in the left direction. And if we have not pressed any key in not the right key, not the left key, then this whole statement will be equal to 0 and the total force that is applied to the rigid body in the x-axis would be 0. So by this way we can identify the direction of the key press, and by this we can add the force in the x-axis according to our needs. Now we'll do the same in the y-axis also. We'll go like in the y-axis we'll go input dot get axis. Now in the x-axis we got the horizontal axis, but in the y-axis we'll get the vertical axis. So we'll write get axis vertical, and again we'll multiply this by move force like this. And in the z-axis we do not want any force to be applied, so we can set it to 0 or we can leave it like this only. So this whole statement will calculate which key you have pressed, and accordingly it will apply the force in the required direction. Now after we have defined the direction and the amount of force we need to apply, we need to also multiply this by time dot delta time, so that it is not the amount of force is not affected by the frame rate, but it is affected by actual time of the game. So we'll multiply both x and y axis with time dot delta time. Now let's add some torque to a rigid body. For that I'll add rb dot add torque, and the torque this torque add torque function accepts a float here, and if the float inside is positive, then the rigid body will rotate in anti-clockwise or left direction, and if the torque is negative, then the rigid body will rotate in clockwise or positive direction. So I want that if I press the right key, then the rigid body should rotate in clockwise direction, that means the torque should be negative, and if I hit the left key, then the torque should be positive, that means the rigid body should rotate in anti-clockwise or left direction. So firstly I'll take this input dot get horizontal dot get axis horizontal statement, and this statement will define the direction we want our torque to be rotated, and I am going to multiply this by negative of the torque force we have created, because if we are hitting the right key, then this statement is 1, and if this statement is 1, then if we have mentioned negative of torque here, then whole torque would be negative and the rigid body will rotate in anti-clockwise direction. And similarly, if we are hitting the left key, then this whole statement is -1, and if we multiply these two, then we are getting a positive torque, that means the rigid body will rotate in anti-clockwise or left direction. But I also want one thing, that if I hit the up key, then the body should also rotate in clockwise or right direction, and if I hit the down key, then body should rotate in anti-clockwise or left direction. So I'll add another statement here plus, and I will add this input dot get axis vertical statement here, and again multiply this by negative of torque. Yes. So what all is happening here, that if I am hitting the right key, then this whole statement is -1, and this vertical statement would be equal to 0, because right is not a vertical key, it is a horizontal key. So this whole statement would be 0, and the whole torque applied to our body, it would be +1 here if you are clicking the right key. So the whole torque applied to the body is -1 minus the torque we are going to specify. So the rigid body will rotate in the clockwise or the right direction. But now if we hit the left key, then this whole statement would be equal to -1, and this whole statement would again be equal to 0, and the torque now applied to the body is 1, and rigid body will rotate in left direction or anti-clockwise direction. Again, if we hit the up key, then this whole statement would be equal to 1. This whole statement would be equal to uh, this whole statement would be equal to 0. So the torque that is applied on the body is negative, and rigid body will rotate in right direction. And if we are hitting the down key, then this whole statement would be -1, and this whole statement would be 0, and the torque that is applying to the body now is positive. So you can see that our controller functionality with respect to the direction is almost complete. Now in the editor, open the player prefab and set the move force to 200 and torque to 500. Also go to the body game object and set its mass to 1, linear drag to 10, and angular drag to 200. You can change these values according to what you found good, but as these works for me, then I'm using these values. Now if we hit play and start the server as LAN host, you can see our player arrived, and it is perfectly moving right, left, up and down as the way we want, and also the torque is applied in a good way and the way we required. But now you can see that the player is moving out of the screen and out of the camera focus. Now we'll create the script to sync this camera with this player. Before that, let's organize some stuff. For that, I'll create a new folder and name it as prefabs. I'll create 2 more folders. The first one is the scripts folder, and the second one is the sprites folder. SPRITES. The prefab one, I'll add the player prefab, and in the scripts one, I'll add the player script, and in the sprites one, I'll add the square sprite. Before creating the script, let's create 2 tags. I'll name them as local player tag and PLAY, local player tag, and other player tag, and these 2 tags would be set up. And in the scripts folder, let's create a new C# script, name it as camera src, and open it on Visual Studio. Now in the camera script, we'll start by removing these 2 using tags, and also remove the start method. Now we need to sync our camera with the body of our local player. So for that, we'll need the reference for the body game object, and I am creating a game object variable and naming it as local. This local variable will store the reference of the body of the local player prefab. Now you can see that when the server is not set up and when you have not joined the server, then the player prefabs are not instantiated, and the local at that time would be null. So we are going to write the script that if local equals to null, that means the reference of the body of the local player prefab is not set up into the local variable. At that time we are going to search for it. So we are going to search like local equals to game object dot find object with tag, and as in the player src we have defined the tag of the body as local player. So we are going to search for the tag as local player. So whenever the scene is not set up or our server is not set up, then the local would be null, and at that time the local would search for any game object having tag as local player. And as soon as the server would be set up, then the player prefab would instantiate with its body, and one of the body would have a tag as local player, and that body would now be referenced to the local variable. And after this happens, that means in the else block, ELSE, in the else block, after it is referenced, that means now local is not null, then here in the else block we are going to sync the camera with the transform position of the body of the local player prefab. So in else part, to sync the transform of the camera and the game object assigned to the local, we are using the lerp method, and the lerp method is used to smoothly transition between two vectors. So we'll write vector3 dot lerp, and this method accepts three parameters. The first one is the initial position, second one is the final position, and the third one is the speed of the transition. So the initial position should be the position of the camera, that is transform dot position, and the final position we are going to create a new vector for that, vector 3, and I'll name it as final pose, and it will be equal to a new vector 3. Now the x part of the final position should be the x component of the local game object. So we'll go like local dot transform dot position dot x. Similarly, the y component should be the y position of the local. So we are copying this and pasting it here, and it would go like transform dot local dot transform dot position dot y. And the z component of the final position should be the z component of our camera. So it will be like transform dot position dot z. So now our final position is created, and now we are going to assign the final position in the second parameter. In the third parameter we are going to assign the speed by which this transition would occur, and the speed is 0.1 f. Also I'm changing this update function to a fixed update function, so that there is no jittery movement while the transition. As now our lerp method is done, we'll assign it to the transform of the camera. So we'll write transform dot position equals to the method we have created. So now in the editor, if I select the main camera and add the camera script into this and hit play now, you can see that the game has started, but the server is not set up till now. And if I go to the inspector of the main camera, and if I click those three lines and select the inspector mode to debug mode, you can see a lot more things have appeared in the inspector now. And by this mode you can see the private variables in our scripts also. So in the camera script, the private game object variable that we have created local is now null. So at this moment the local is not referencing anything, so camera's position is not synced with any game object. Now as soon as I click on the LAN host and start the server, the player prefab has been instantiated, and with the player prefab you can see the body is also instantiated. If I click on the body, you can see that it has been assigned the local player tag, but the player prefab stack is still untagged, because in the player src script by runtime we have set up the tag to local player. And now in the main camera you can see that as the body has arrived in our scene and its tag is local player, so the local variable has been assigned a game object, and this game object is the body. You can see that it is appearing here, is the body that is instantiated. And if I try to move this body, you can see that the camera's position would be smoothly synced to the body. If I am going to the left direction, you can see that yes, the camera's position is syncing. If I am going left and right, and if I am going up and down, also the camera's position is syncing with the position of the body, and the game object or the body game object is now not going out of the focus of the camera, and this is what we needed. So by this way, as each device that is connected to the server would have only one main camera, and that main camera would be synced with the body of the local player prefab of that device. So whenever someone plays the game, then the local player of that person would never go out of the reach of the camera and would always stay inside the bounds of the screen by this script we have created. Also, one last thing we need to do is as all the player prefabs in the server would have this player script, and we only want that a particular device should control its local player prefab, so we can add an if is local statement here at the before the controllers of before adding the force to the player. We want to check if the player is local or not, because for one device we only want that that device should control its local player, and the movement of all the other players should be synced by their local devices only. So this is the final product that we have created, in which we have two devices that are connected to a server, one as a LAN host and local host, and one as a client. Also, each device is only being able to control a specific player, that is the local player for that device, and for each device the local player is of blue color and other players are of red color. So for example, if I take the example of this device, then there is a blue player and a red player. The blue player is the local player for this device and red player is any other player. So suppose we have 5 players in our game, then one player would be of blue color and rest 4 players would be of red color, and the blue colored player is our local player. Also, as each devices have one main camera, that main camera would be following the local player of that particular device, and we are controlling the local player of a device by adding some force and torque to it. So by the control keys you can see that I can move my player, and that transform is being synced to the other device. Similarly for this device also, now I can see that the transform of this player is being, although is being synced to this device, but it is not very smooth. It is quite slow and quite laggy. This is because currently I am screen recording with my screen, and at the same time I am playing the game, and because the computer is not very fast, that's why it is such a laggy stream. But if you are not screen recording and if you are just playing your game, then it would be very smoothly synced. Also, you can create your own script to optimize the syncing process and things like that. So that was all for today.
Success depends upon the second letter U. Thanks for watching this video. If you liked it, consider subscribing and hitting the like button. Also press that bell icon so that you are notified each time I post a new video. Make sure to share this video with all your game dev friends, and feel free to comment your suggestion, opinion, queries down in the comment section. We'll see you in the next video. Till then, dream big, hustle hard, and keep watching How to Game Dev.